My name is David, and I'm one of the ACT Science instructors here at Hamilton. Today we'll be going over ACT Science tests from 198. But before we do that, I would like to remind you about the structure of the ACT Science test. The ACT Science test has 40 questions, but they're always broken up among 6 passages. You only have 35 minutes to do 40 questions, which is not a long time. So you want to aim to do each passage in about 5 or 6 minutes. It's very challenging to do. With practice, you'll get better. So let's go over the passage types. There are 3 of them. Data representation, I like to call DR. They have the shortest amount of text and 1 to 4 figures. And there are usually 2 of those per test. Research summaries have a medium amount of text. There's still about 1 to 4 figures, but there will be 3 of these per test. And lastly is the conflicting viewpoints. There will only be 1 of these per test, and they usually have the most amount of text, and they compare 2 or more viewpoints. And we'll talk about how to do that one too today. All right, let's get started. Hello, this is David again. Passage 1 for ACT Test 198. So the first thing I noticed about this passage is that it has a very short amount of text, and there is a chart here. This tells me it's a data representation passage. So what I'm going to do, instead of reading this information, is I'm going to go straight to the questions and see if I can figure it out from here. Question 1. Of the following combinations of types of mulch and mulch age, which combination resulted in the greatest mass consumed by the R. flappies? Well, looking at this, I can see mulch consumed is the y-axis, and I can see mulch age is here. And I notice that there's a key, and there's oak and pine bark. So if I look at oak at 24 weeks, that is going to be the gray one, 24 weeks. It looks like it's 160. If I look at pine bark at 24 weeks, that is less than 160, so that's probably not our answer. But I think it's about 150. If I look at C, oak, 48 weeks, oak is gray bar. Wow, that's a lot lower, so that's not our answer. But I would estimate that to be around 50. And then pine bark at 48 weeks, well, that's a little bit higher than the previous one, but still much lower than our first choice, A. And so I'm going to put that at 60. But for now, I can clearly see that the answer is A because we're looking for the greatest match of mulch consumed by this creature. Question number 2. Which of the following statements about the effects of mulch age on the consumption of mulch by R. flappies is consistent with the figure? All right, well, there's only one figure, so it has to be related to this. As mulch age increased, again, mulch age is down there, from 1 to 48, so we're looking at all 3 of these, the mass of mulch consumed. And it didn't say which specific type of mulch, but we're going to be looking at all of the mulch for these 3 weeks. So it decreased for all 5 types of mulch. Well, I can see that it clearly goes up from 1 to 24, so I know it's not F. It increased for all 5 types of mulch. Well, it did go up initially, but then it went down for the 48 week. So it's not G either. H, initially decreased for all 5 types of mulch, but then increased for some of the 5 types of mulch. Well, it went up initially for at least the oak, so we know it's not that one. And J, initially increased for all 5 types of mulch, but then decreased for some of the 5 types of mulch. And that looks correct because, for example, the oak bark went up the entire time, whereas the oak went up and then decreased. So J is our correct answer. Question number 3. Based on the passage, would R. flappies be classified as an autotroph or a detrivore? And why? So, I don't know what an R. flappies is, and you may not know what autotrophs or detrivores, so we're going to look at both of those topics. Looking at the passage, it says the termite consumes wood and bark. A study examined whether the consumption of wood and bark mulch by R. flappies varies with the type of mulch. Separate portions of each of the types of mulch were aged, and then more mulch in a box, more mulch in a box, more mulch in a box, okay, but nothing is talking about whether it's an autotroph or detritivore. So that tells me this is an outside knowledge question. So I was supposed to remember from my biology class what an autotroph is and what a detrivore is. Now, in case you forgot, an autotroph is an organism that makes its own energy, and a detrivore is an organism that breaks down organic material. There is a bonus fact if you want to know it, and that is a heterotroph is an organism that gets its energy from eating other creatures, such as cows and humans. We eat other things that are alive to get our energy. But we're looking at the difference between an autotroph, which is like plants that get their energy from the sun, or detrivores, like fungi that break down things. Well, looking at this, termites do not get their energy from the sun, so I know it's not an autotroph. So let's look at the other two remaining choices. Detrivore, because it produces its own energy without consuming organic material, or detrivore because it gets its energy by consuming decaying organic matter. Well, it says it consumes wood and bark, so I'm going to pick D as my final answer. Question number 4. Based on the passage, is the primary food source of our flapes most likely cellulose or cholesterol? Well, we just read the passage and it did not mention cellulose or cholesterol at all. The only thing it mentioned is that it eats wood and bark. So this is another outside knowledge question type where you have to remember that cellulose makes up the cell walls of a plant cell, whereas cholesterol makes up the cell membrane in both plant cells as well as in animal cells. So let's read the answer choices. The primary food source, is it cholesterol? Is it cellulose? Cellulose. Well, the cell membranes of animal cells and the cell membranes of animal cells contain cellulose. Well, we were not eating animals. We were eating plants. So it's not F. G. Cellulose. Phosphate is consumed to cell walls of plant cells, and cell walls are made of primarily cellulose. So they do have some cholesterol, but mainly it's cellulose. So that is our correct answer. But if you want to check the remaining two, we can. Cholesterol, well, no, it's eating cellulose with a plant material. So we can cross this one off. And cholesterol, again, seeing the plant cells. But if you read the whole thing, it can seem kind of true. So if you did not know what cellulose was made of, J sounds like a very plausible answer. Question number 5. Which of the following statements comparing the consumption of our lapis of 1-week-old mulch, 24-week mulch, and 48-week mulch is supported by the figure? So we're going to be looking at the figure again. More 1-week-old was consumed than 24-week-old mulch. Well, looking at the figure, I think 24 is bigger than 1 week. So, oh, actually, we're not looking at all of it either. We're looking only at the oak mulch. So let's highlight that. So we're looking at this middle bar. And I can see that it went up, then down. So I want the one that says 24 weeks is the greatest, and week 1 and 48 are smaller. So it's not A. B, less 1-week mulch was consumed than 24 weeks. That's good. So that's a check mark. And less 24-week was consumed. Well, no, we want more. So it's not B. C, more 1-week mulch was consumed. Then 24-week? No, that's definitely less. So it's not C either. D, less 1-week-old mulch was consumed than 24-week-old mulch, and more 24-week mulch was consumed than 40. Finally, we got the correct answer. The answer is D. Question number 6. What mass in grams, not milligrams? So this is clearly italicized and drawing our attention, so we probably have to do some conversion. Of the 40-week-old oak bark, which was consumed by our flapes. So I'm going to go to 48, I'm going to go to oak, which is right here. And then we need to convert this number into into grams. So that means we're going to divide by 1,000. So let's take our values. So Oak Park, we have this level right here, and I can clearly see it's at 140. So it's 140 milligrams. Now, I remember that for every 1,000 milligrams, or like millennium, that makes up 1 gram. So I need to divide this by 1,000, which is going to move the decimal over 3 places. That's going to give me 0.140. So that should be answer choice G. If you thought the answer was J, you unfortunately moved it only 2 places, which is dividing by 100. And there you go. Hi again. This is going to be passage 2. So my first thoughts about looking at passage 2 is that there's a short intro describing the passage, but very importantly, there's experiment 1, experiment 2, and I notice that there are 2 graphics or tables, as you can see here. This tells me this is a research summary passage or a Reese's passage, whatever you like to call it. So my strategy will be still to go to the questions first, and we'll get started on that next. All right, question number 7. Which of the following statements best describes a difference between experiment 1 and experiment 2? So for these types of questions, we are going to be looking at experimental design, or how the experiment was set up. So usually that's located right after the words of the experiment. And we can read both experiment 1 and experiment 2, but usually for a lot of ACT science passages, the second and third experiments usually copy each other, and then they tell you what they changed between the two. So instead of looking at experiment 1 first, I'm going to look at experiment 2 first. The scientists repeated experiment 1 except with strain V2 instead of strain E. The results are shown in table 2, and I can see that right here. Looking above, the temperatures are the same, the weeks are the same, the months are the same. Answer choice A. A different incubation temperature was tested in experiment 1 than experiment 2. Well, we see they have the same temperatures, so it's not A. B, a different strain of species C was tested. Well, that says strain, and those were changed, so that is the answer. Let's look at the other two. Samples in the experiment were lyophilized before being transported, whereas samples in experiment 2 were transported on ice. They don't mention that here, so we can probably cross off C. The samples in experiment 1 were incubated for 1 week before being transported, where samples in experiment 2 were incubated for 1 month before being transported. Well, this shows us 1 week and 1 month, so I don't think those were the differences between the two. And I think B is a much better answer based on what we have. Question number 8. So suppose in experiment 2, the scientists have determined the percent survival for a sample incubated at 25 degrees for 1 week. So looking at that, we're looking at experiment 2, and it says 1 week. So I have a 1 week here. And we're looking at 25 degrees Celsius, so it's between 20 and 30. So I'm going to probably guess a number, it's between 29 and 2. The percent survival of strain V2, again, which is the right strain. The elementary bodies in the sample would most likely have been between what? Well, it's between 2 and 29, so it's not 0. Definitely looks like G, not H, not J. So the G is our correct answer. Question number 9. At which 2 temperatures, all right, we need to pay attention to that, was the percent survival of strain V2 and was less for the longer incubation time than for the shorter incubation time. So we want when is the longer or the 1 month less than the 1 week. And because it says strain V2, I'm going to be looking at table 2 where it has V2 right there. Okay, looking at 4 degrees and 20 degrees Celsius, we have 4 degrees and 20 degrees. Is the 1 month incubation time less than the 1 week incubation time? That looks correct from what I can see. 59, 6 is less than 59, and 4 is less than 29. So that seems like the right answer. Let's look at B though. 4 and 37. Well, 4 is still less than, but 37, they're tied, so it's not a shorter period of time. C, 20 and 30. So we got 20 and 30. Those are, again, less than, but tied. So that's the same as B. And then 20 and 37, 20 and 37, again, less than and tied. So A is the only case where both, for both temperatures is the 1 month less than the 1 week. So that's why I picked A. Question number 10. Which of the following questions was not addressed by these experiments? Answer choice F. Does incubation time affect the percent survival of strain E and strain V2 elementary bodies after lyophilization? Well, looking at these two charts, I can see that the time after the incubation occurred does seem to tell us what percent survival is occurring. So I think answer choice is addressed here. Answer choice G. Does temperature affect the percent survival of strain E and V2 elementary bodies after lyophilization? Again, we have temperature given here, and that does seem to affect the percent survival rate. So I'm going to cross off G. H. Does the number of strain E or strain 2 elementary parties present in a sample before lyophilization affect the percent survival? That seems like a good answer to me, but we'll keep checking. Do the strain of elementary bodies in have a greater percent survival than strain V2 elementaries after lyophilization and incubated? Well, looking at the data here, we have incubation time and the different strains, so we can cross off J. So we could pick H as the best answer choice, but if you want to be able to prove the answer, you would have to go to the experimental design setup. In the experiment 1, it says scientists place 100 microliters, a sample of a nutrient medium containing 4 times 10 to the 6 strain E elementary bodies into each of the 8 sterile test tubes. They then followed repeating this experiment for strain V2. So because they did not change the number of elementary bodies, we could not answer that question. And that's why the final answer is H. Question number 11. 1 week after the start of the incubation, so 1 week, which of the 4 samples of strain V2 would have been least likely to infect another organism that came in contact with the samples? So because it's V2, we're going to look at table 2, and we can look at the first one, incubate at 4 degrees Celsius at 1 week. Well, there are 59 still surviving, so that seems like it would have a high chance of infecting another organism. Next on the list is 10 degrees, which is going to be between 59 and 29. Next, we have 20 degrees Celsius, which is going to be 29%. So that's lower, so that's looking better. Then we have lastly 37 degrees Celsius. Well, that's 0 elementary bodies remaining. So I think D is the best answer in this case, because if we have none of the bodies in there, then there will be no chance of infection occurring. Question number 12. Suppose that a scientist wants to transport a lyophilized sample of strain E, so we're probably looking at table 1, based on the results of experiment 1, so still table 1, which of the following combinations of temperature and transportation time would most likely ensure the greatest percent survival? Well, looking at this, I can see that at 20 degrees and 1 week, that had the most survival. Let's see if that is an option here. We have 4 degrees Celsius 1 week, which is 52. We have 4 degrees Celsius 1 month, which is 51. And we have the 20 degrees Celsius in 1 week, which is the highest number there. But we'll check J just to make sure. 20 degrees Celsius in 1 month, that's 42, which is the lowest answer. So that is why I picked answer choice H here, because it was the highest number, and we were looking for the greatest percent survival. Question number 13. Consider the rating system in the table below for the percent survival of elementary bodies after lyophilization. So we have the table here. Based on this table, what is the total number of tubes used in experiment 1 only that contain samples of having a 4% rating. So we're looking for tubes less than 30%. So looking at experiment 1 only, I see that there are 4 numbers that are less than 30. So the answer is 4. However, you may have thought that it was only 1 test tube per temperature. So the way we can prove that indeed it is 4 is back in the experimental design setup. They used 8 test tubes for this experiment. So that's why it's for each temperature and amount of time, they had its own separate test tube. So that was why the answer is B, 4 test tubes instead of A or D. On to passage 3. So one thing I noticed about this passage is it had study 1 and study 2. It also has 2 figures and a table. So this is very likely to be a research summary passage or a recess passage. Also, looking at the shapes in here, it reminds me of Archimedes' principle, which you may recall from your physics class. But now we can go on to the question. Question number 14. Based on the results of study 2, as the density of the fluid of stone X was submerged increased, the buoyant force in stone X did what? So I'm going to study 2, and I see that there's table 1 right here, there's stone X, and I have 3 different fluids here. Now, I don't know how these densities compare, but I can find that information right here. So water is at 1, fluid A is at 1.25, and fluid B is at 1.5. So it increases the density as we go from left to right. The density goes up. All right, so let's look at the buoyant force. Well, the buoyant force went from 0.47 to 0.59 to 0.70, so that looks like it increased only. So looking at my answer choices, it's not decreased. There it is right there, increased only, or answer choice G. Question number 15. Based on the results of study 2, so again, we're looking at the same place, but this time for stone Y, what was the difference between the buoyant force in fluid A and the buoyant force in fluid B? So going to stone Y, and we have fluid A right here, and then fluid B right here, and we want to find the difference, or in this case, subtraction. So 1.41 minus 1.18. Now we don't have a calculator, but this is like the ones will cancel, and I'll get 41 minus 18, which is about 20 something. So the closest answer is B, which is a quick way of getting that answer. If you want to do subtraction, you're welcome to, and that would be a good way of finding it. But we know it's not 11 because 11 plus 18 is 29, and we know it's not 47 because 47 plus 18 is 65. So the answer is B. Question number 16. Suppose the students decided to study whether a cylinder's volume determines the submerged length of the cylinder in a given fluid. Okay, there's a lot to process right there. Which of the following procedural changes should the students take to make study 1? Well, study 1 is where they use the cylinders here. All right, so let's go through the choices. A single cylinder with multiple fluids, the fluids should each have the same density as the cylinder. Well, if we're looking to see if the cylinder's volume determines the submerged length, if we only use one cylinder, there's not a way to see how the volume would change or determine it. So we probably need to use multiple cylinders. So I'm going to cross off F because it has that. For G, it also starts a single cylinder, so we can cross off that one as well. So let's look at H and J. They both have multiple cylinders with a single fluid. The cylinders should have different volumes but the same density, or they should have different weights but the same volume. Well, we're seeing whether the cylinder's volume determines the submerged length here. So if we use the same volume, you wouldn't be able to notice a difference here. So we want different volumes but the same density. And that's why I'm picking the answer H. Question number 17. In study 1, did the cylinder displace a greater volume of water or a greater volume in fluid A? So displace is a great word to know. It means to move out or replace or shift out of the way. So one of the things you can recognize this is if you have a bathtub filled with water, if you stand in the bathtub, the water height will go up a little bit because only your legs are submerged. But when you put your whole body in the bathtub, then the water will go up a lot more because you have displaced a greater amount of volume of water. So using that information, let's look at figure 1. So looking at the three figures, I can see that water displaced at greater height because the cylinder submerged 7.4 centimeters below, whereas in fluid A, only 5.9 centimeters of the cylinder was submerged. So look at the answer choices. Water, because the cylinder's submerged length was greater in water than fluid A. That's the right answer, but we can look at the other ones to cross them off. Water, because the cylinder's submerged was greater in fluid A. Well, those are contradictory statements. You can't pick water, but then say something that's not true here. The submerged length was greater in water, not in fluid A. So this is like contradictory right here. Fluid A, because the cylinder's submerged length was greater in water. So that second part is true. So if you didn't know about um, what you're looking for, whether you want the cylinder to be higher up or further down, C makes a good tempting answer because at least the second half is a true statement. Fluid A, because the cylinder's submerged length was greater in fluid A than in water. So again, the second part of the sentence is not true. And we can see that here, that it's more submerged in the water than in the fluid A. And that's why the answer was A. Question 18. Suppose that in study 1, so again, study 1, the students had placed the cylinder in a container of fluid having a density of 1.60 grams per centimeter cubed. Well, that is greater than what we put in fluid B. The submerged length of the cylinder would most likely have been what? Well, looking at study 1, as the density increased, the amount of submerged depth decreased. So we want a depth less than 4.9 centimeters. It would be less than 4.9 centimeters. Perfect. That's the answer. And that's why the other three are not. Question number 19. Suppose that in study 2, the students had tested stone having the same weight as stone Z, so that looks like it was 3.0, but a larger volume than stone Z. So then maybe 100 or 120 or 200. Which of the following statements about the buoyant force on the submerged stone would be correct? The buoyant force in stone is going to be what in water less than 0.94, fluid A would be less than 1.18, fluid B greater than 1.41, or it would have been greater than in stone A. So we can't really determine going off of here because there's some changes, but there are some things that are held constant. So if you compare stone X with stone Y, they have the same weight, but they have different volumes. The volume increased. So looking at those, I can see that the buoyant force for each of them increased. So when weight is constant and volume increases, then the buoyant force increases. Well, let's see what happens if we keep the same volume, but we change the weight. So if we keep the same volume and change the weight, nothing happened here. So it seems like weight changing does not have any effect on the buoyant force. So volume constant, and then weight goes up. The buoyant force is the same. So although it says that it has the same weight as stone Z, it has a larger volume. So because it has a larger volume, I would expect the buoyant force to go up. So let's look at the options that support this. Water would have a buoyant force less than 0.94. Well, it should go up, so it should have a buoyant force greater than 0.94, so it's not A. Fluid A would have to be less than 1.18. No, that should be greater than as well. So both A and B are wrong because these are supposed to be greater. Fluid B would have a greater than 1.41. Perfect. That looks like the right answer. And let's check C. D. The water would have been greater than the buoyant force on this end in fluid A. Well, that is not true because the water has always been less than the buoyant force in fluid A. The final answer is C. Question number 20. Assume that the Atlantic Ocean water has a density of 1.01 and the Pacific Ocean water has a density of 1.03. Okay, so they're similar, but the Atlantic Ocean is less. So AO is less than PO. Based on results of study 1, in which ocean would a given iceberg more likely have a greater submerged volume? So looking back at study 1, I want to see which of these following choices would have a greater submerged volume. And I can see here, back when the water density, the density of the fluid was lower or the lowest, it had a greater submerged volume. So that's the answer I'm looking for. So let's look at F. The Atlantic Ocean, because the results of study 1 indicate that the submerged volume increases as the fluid density decreases. That is exactly right. So F is our answer. But let's look at G to make sure. The Atlantic Ocean, because the results in study 1 indicate the submerged volume decreases as the fluid density decreases. Well, that is not true. So we can cross off G. H, the Pacific Ocean, because the results of study 1 indicate the submerged volume increases as fluid density decreases. So again, once again, the second half of the statement is true and supports the data, but in the question, it said the Pacific Ocean was the greater density. So we wanted the one with the smaller density, which is why it's not H. And then J has both the Pacific Ocean, which we know is not true, and it repeats what we saw in G, so we can cross that off as well. And we're done. On to passage 4. Once we have passage 4, once again, we have an experiment, and I see a table of data as well as a chart right here. So this is going to be our last research summary passage for this science test. Let's go on to the questions. Question number 21. If a trial had been performed with 60 milliliters of NaClO with a solution with 40 milliliters of NaI solution, the TF would most likely have been which of the following? So looking at table 1, I have 60 milliliters of NaClO, which is going to be between the 50 and 70, and the 40 will be between the 50 and 30. So since I'm looking for TF specifically, it should be between 29.0 and 31.7. So 29.0, and our TF will be 31.7. So is it less than 25.5? No, it should be more than 25.5. Is it between 25.5 and 29? No, it should be greater than 29. See, 29 and 31.7. That's perfect. Got our answer. And just to verify, it's not greater than 31.7. So the answer is C. Question number 22. Before the experiment, a student predicted that the delta T, or triangle T, for trial 2 would be greater than triangle T for trial 6. Do the results in table 1 support this? Well, let's compare them. Here's trial 2. We got 3.5. And then we have trial 6, which is 8.6. So trial 2 is less than trial 6, so that does not get supported. So we're going to cross off all the yeses. So F, no, the delta T for trial 2 was 5.1 less than the delta T for trial 6, or the delta T for trial 2 was 8.6 less than the delta T for trial 6. Well, 3.5 is about 5.1 less than, so that is why I'm going to go with answer choice F here. Question number 23. In each trial, the total volume, again italicized, so that we're looking for the total poured in the solution was what? Well, looking at each of the trials, the total volume is 100 each time because 0 plus 100, 25 plus 75, all the way down to the 100 and 0. So that is why the answer was D, 100 milliliters. Question number 24. Consider the trial for which the volume of NaClO was 4 times as great as the volume of NaI. So 4 times as great as the volume of NaI. So that means we're going to be looking for a case where we can multiply NaI by 4 and get the other volume. So looking at them, I see that we have 20 and 80 for trial 6, and we're looking for TF in that case, which is 30.6. And that is why the answer is H. Question number 25. Suppose a trial had been performed with 20 milliliters of NaClO and 80 milliliters of NaI. So looking here, we want 20 milliliters of NaClO, which is between 0 and 25, and 80 is between 175. But it's closer to trial 2. The delta T for this new trial will most likely be closer to which of the following. So it has to be between 0 and 3.5. So we can cross off D and C because those are greater than those values. But this is where it gets a little difficult to determine whether it's 1 degree Celsius or 3 degrees Celsius. My reasoning is that since 20 milliliters is much closer to 25 than it is to 0, I think our temperature should be closer to 3.5 than to 0. So that's why I picked the answer B in this case. Question number 26. Which of the following statements best explains why the delta T was 0 degrees Celsius for trial 8? The volume of the solution added was milliliters for one of the blank. So for trial 8, we have 0 for NaI. So NaI, is that a product or a reactant? So this is an issue that you may have run into your chemistry class, where reactants are on the left side of the chemical reaction. So we have reactants on the left, and then they always yield, that's what the arrow means, products on the right. So since Na is on the left, it's not a product, it would be a reactant. So we can cross off F and G. So then next on the list is that NaClO is 0, so no reaction has occurred, or NaI is 0, so no reaction occurred. Well, looking back here, we see that NaI is 0, so that's why we picked J as our answer. Question number 27. Suppose the reaction study had been endothermic. As the endothermic reaction progressed, would the solution temperature most likely have decreased or increased? So an endothermic reaction is when heat is absorbed. In this reaction that we studied today, it was an exothermic reaction because heat was released. So it's a good outside knowledge fact to know, as well as a good thing to know for your chemistry class. So going back to this, if it's an endothermic reaction, the temperature should have decreased because you'd be absorbing the heat from the area, the surroundings. So because the temperature decreased, I would cross off C and D because they say increased. The reaction would have released heat. That's for exothermic, so it's not released. And then B, decreased because reaction would have absorbed heat. That is the definition we wanted. On to passage 5. With this passage, we have a lot of graphs going on right here, but there are no experiments left over. And that's because we've done all the research summary so far. So this tells me this passage is a data representation passage. So once again, we're going to go to the questions. Let's begin. Question number 28. The first mistake you may have done is accidentally jumped over to question 30 to start off, but sometimes they do put questions on the same page as your passage, so watch out for that. According to figure 2, at 300 MPAs, the solubility of CO2 in the Rhyolite magma is closest to 2000 ppmWs at which of the following temperatures? So let's go through that. Figure 2, at 300 MPAs is along this line. The solubility of CO2, which is this table, of Rhyolite magma, which is also in this table, is closest at 2000 ppw. So 2000 ppw is using the y-axis. So I want to look and see where it hits the grid lines at that point. And we're looking for which temperature. So the temperature looks like it's at right around 800 because it's right in the middle of 750 and 850. So it's not 700, that's too small. It's not at 750. Oh, there we go. There's 800 right there. So that's perfect. and then it's not 850 either. Question number 29. Based on figure 3, at 750 degrees Celsius and 350 MPAs, the Rhyolite magma would have a solubility of CO2 equal to 1250 ppmWs, and most likely have a weight percent of water that is what number? So figure 3 is where we're going, and we want 700 degrees Celsius, which is part of all the data points, and 350 MPAs, which is between the 300 and 400. So I would estimate it would look something like that, where it would go between the two curves. And we want 1250 ppmWs. So 1250 is between 1000 and 1500. So we're kind of looking right down the middle where it hits that blue line. So I would estimate that it's around 5.5 or 5.25, something like that. Perfect. So let's see what answer that matches up with. So we want around 5.5, 5.25, so it's not less than 2, it's not between 2 and 4, but C looks perfect because it's between 4 and 6. So that is why I would pick C. Question 30. According to figure 1, at 1150 Celsius, the solubility of CO2 in basanite magma and the solubility of CO2 in theolytic basalt magma, so very similar sounding but slightly different, are closest to which of the following pairs of pressures? All right, cool. So these are separate. And we're looking at 1150 at figure 1. So there's figure 1. And one thing you might notice again, in this case, there's no temperature in part of the graph because it's provided for all of them. But we were looking for 2 of them, the theolytic basalt and the basanite. And we were looking to see which of the following is when they are closest in value. So at 50 MPAs for the basanite magma, that would be right around here. And the theolytic would be at 200 MPAs, which is right about here. So those look pretty close to me. So let's see if there's a closer one. All right, so again, still 50, but 250. Well, I think going at 250 made them further apart. So G is not as good as F. How about H? Now we're looking at 125 for the basanite, which is right there, and then 200. So again, it's a little bit higher than what it was previously, but it's still not the same. So I don't really see a difference between F and H right now. They're pretty close. J, 125 and 250. Well, they're basically on the same grid lines. So these are exactly the same. So that is why the answer is J. All right, question 31. Based on figure 1, so we're going back to here, at 1150 Celsius, which we know is not important because temperature didn't matter, 150 MPAs, which does matter, the solubility of CO2 in lucite is approximately how much greater than or less than the solubility in rhyolite. So we're kind of looking for the difference between these two at 150. So at 150, lucite is definitely the greater number. I'd say that's about 3,000. And then the rhyolite, 150, I don't know, about 750, 800. I'm just going to make it 800 to make the subtraction easier. That's 2,200. And the leucite is greater. So we have to make sure we answer that correctly. The solubility of leucite is going to be greater than, so we don't want lesser. And then we want about 2,200, so I'm going to pick B as the correct answer because 2,300 is closer to 2,200 than 1,750. Question number 32. According to figure 2, increasing the temperature from 650 to 1150 has the lesser effect on the solubility of CO2 rhyolite magnet at which pressure, 100 or 300? All right, so we're going from 650 to 1150, and we're comparing the 100 and the 300. So looking at the 100 MPAs, the slope of it is not as steep, so the rate of change of it is not as much. So as we increase the temperature, the 100 MPa did not change as much as the 300. So I'm looking for the 100 because the slope is less. All right, so we don't want 300, but 100. The solubility of CO2 decreased by about 400 ppmws or 1300. Well, it started around 800 and it ended around 500. So went from 800 to 500. That's a decrease of about 300. So I'm going to pick F, which is 400, because that's much closer than 1300. All right. Question 33. Consider the solubility of CO2 in rhyolite magma at 750 degrees Celsius at 200 MPAs as shown in figure 2. According to figure 3, the rhyolite magma has a weight percentage of H2O closest to which of the following. So this is probably a data bridge or a cross bridge where we're going to have to connect the two graphs together. So let's start with figure 2, 750 Celsius at 200 MPAs. So 750 at 200 MPAs is right there. And that gives me 1500 solubility. Let's write that down. So let's use this information at figure 3. And the key thing here at figure 3, it was already 750 degrees Celsius. So that's why we can make this bridge between the two. So we want 1500 of the 200 MPAs. And look at that. That is right at 0 weight percent. So that's what we're looking for, something very close to 0. D, C, and B are too big. And so the correct answer is 0% or A. Congratulations, you've made it to the final passage of this week's ACT science test, passage number 6. This is a conflicting viewpoint passage, and it has 2 viewpoints. And I can tell this because it has a hypothesis 1 here and a hypothesis 2 here. Other clues will either say student 1, student 2, student 3, or they'll say scientist 1, scientist 2, scientist 3. All right, your steps when you're doing the conflicting viewpoints is different than the other 2. I recommend that you identify the question, which is usually right before the first argument. So here's our question. So it says 2 hypotheses were proposed to explain why the planets occasionally appear to move retrograde. So that's what we're looking for. So the hypotheses or arguments are usually in the first part of the body. So for hypothesis 1, it says Earth is the central body and the other objects move around it. So Earth is central. And for hypothesis 2, it says the sun is central. All right. The next thing we want to do is label our questions so we can then decide what order to approach this test. So you don't necessarily have to do this step, but you might find it easier to do all one type of question than the other. So for question 34 here, it says a hypothesis 1. So, but it also says the 2 hypotheses. So we need to know both hypothesis 1 and 2 to answer this question. For 35, it says figures 2 and 3 are drawn to scale. So we need to look at both figures 2 and 3 to answer this question. 36, figures 1 and 3 and hypothesis 2. So 1 and 3 and hypothesis 2. 37, based on figure 1. So that question might be the easiest one to answer because it's only have to look at one place to answer it. But we'll keep going. 38, a support of hypothesis 1 and a support of hypothesis 2. So that's probably going to be both of them. Based on figures 1 and 3, if hypothesis 2 correct, so we want to answer hypothesis 2. And then lastly, 40, can hypothesis 2 explain why Venus occasionally appears to move retrograde? All right, so looking over this document, I kind of see that there's a lot of hypothesis 2s, a lot of figures. So if I was taking this test, I would probably do 39 and 40 first, then do the figures, then do hypothesis 1 and 2 combination. So that is how I recommend you take the test, but in order for to do this test review video, we will be going through the questions in order. All right, let's look at question 34 next. Question 34. Which of the following statements best describes a primary difference between the two hypotheses? Well, hypothesis one was about the Earth being in the center and everything going around the Earth. And hypothesis two was that the sun is at the center and the Earth and the rest of the planets go around it. So let's look at the first one. The looped orbits around the Earth, whereas hypothesis two comes out all planets follow the elliptical orbits around the sun. That sounds pretty good. G, the loop orbits around the Earth, where hypothesis two claims that all planets follow the elliptical orbits around the Earth. Well, that's not true. It's around the sun. Elliptical orbits around the sun. That's the opposite. Well, around the Earth, and then around the sun. So again, this is wrong too. So that's why the correct answer was F, because it was about the Earth, and then the elliptical orbits around the sun for hypothesis two. Question 35. Assume that figures 2 and 3 were drawn to scale. Which of the figures, if either, implies that the distance between the Earth and Mars varies with time? Well, as I look at the figure 2, I can see that Mars and the distance between it and Earth changes over time. So sometimes it's closer, sometimes it's further away. And then for figure 3, it's the same. Sometimes the distance between Earth and Mars is close, and sometimes it's further away. So I would pick both figures would show this. Question number 36. Consider both the interval of time and in figures 1 and 3, and the reason that, according to hypothesis 2, the line of sight from Earth to Mars drifts over time. All right, is the top portion of figure 3 consistent with that reason? So looking at just this figure, I can see that the Earth is a smaller orbit or smaller radius from the sun than Mars. So it has a smaller orbit, that's a good thing. G, it has a larger orbit, that's wrong. Earth is a small orbit, that's okay. And then it has a larger orbit, that's wrong. So we are narrowing it down to either F or H. And so the question that we need to decide is whether or not it's consistent with it. So I think looking at our terms, it said that if it has a smaller orbit, it would take a smaller time to complete, which doesn't seem to be true. And then we have a note here that says if a planet with an orbit larger than Earth pairs to move retrograde whenever Earth passes between the sun and the planet, the larger that planet's orbit, the more often a pass occurs. So as Earth goes here and Mars goes around there, that kind of coincides with the retrograde movement that we're seeing here. So that is why I'm going to go with yes. The answer is F. Question number 37. Based on figure 1, as viewed from Earth, approximately how many days between July 2005 and February 2006 did Mars move retrograde? So that's a very long period of time, but it coincides with what we see in the graph. So there's July of 2005 up to February 2006, but we only want it when it was retrograde or to the west. So that would be along this point in time. So that's from October 1st, 2005 to December 10th, 2005. So it's October 1st to December 10th. So there's approximately 30 days in a month. So I'm going to do 30 plus another 10 to get up to about 70 days. So 30 plus 30 plus 10 is equal to 70 days. And we're going to pick the one closest to that. So not 30 days, not 1 month, but B looks perfect. That's exactly what we want. Question 38. A supportive hypothesis 1 and hypothesis 2 would most likely agree with which of the following statements? So we're looking for a fact that they would both agree upon. When viewed from Earth, if a planet appears to be moving prograde, the planet is actually moving which of the following directions? Well, one thing I know is hypothesis 1 said things were on the Earth, and hypothesis 2 said objects were on the sun. So F is only hypothesis 1, and H is only hypothesis 2. Secondly, they both agree that's going around some central body. If you review their notes, though, they said both circles rotate around counterclockwise around the motion, as we can see that here as well. But the retrograde and prograde is not about the counterclockwise rotation. It's about whether it's going towards or between another object. So although it's tempting to pick G because it's the opposite of retrograde, prograde is the opposite of retrograde, they both agree upon is that objects move counterclockwise around the central body in the solar system. And that's why the answer is J. Question number 39. Based on figures 1 and 3, if hypothesis 2 is correct, which of the following figures most likely shows the positions of Earth and Mars on November 7, 2005? So November 7, 2005 comes into play with figure 1, where November 7th is probably this time right here or close to it, right in the middle. So now when I look at figure 3, I kind of want to know where should the Earth and Mars be so that way it lands right in the middle there. So if I notice if the Earth is to the left of Mars, it was October, and if the Earth was past Mars, it was in December. So I'm kind of looking in place for Earth to be basically right on top of Mars. So let's see, this one right here, that looks like December. This one right here, that one looks like October. So could it continue out? This one right here, that looks pretty good because they're right on top of each other. And this one, they're not blocking each other, not between the Earth and Sun, so there would be no viewing of it. So that's why B is the correct answer for this question. All right, we made it. Question 40, the final question for the science test. Let's go through it. Can hypothesis 2 explain why Venus occasionally appears to be moving retrograde? Well, let's go through hypothesis 2. One of the notes about hypothesis 2 said that a planet with orbit larger than Earth appears to move retrograde when Earth passes between the Sun and the planet. And the second one is a planet with an orbit smaller than the Earth appears to move retrograde when the planet passes between the Sun and the Earth. So both for orbits greater than Earth or for orbits less than Earth, hypothesis 2 can explain it. So that's why the answer is yes. However, how do we know for the following part? Hypothesis 2 accounts for the motion of planets that are closer to the Sun than Earth, or it accounts for planets that are further from Sun than Earth. So this is, again, another outside knowledge check where we had to remember that the order of the planets is Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, and then from there we have Saturn and Uranus. Sorry, Pluto, you're not going to make the cut. Right? So because I know that Venus is closer to the Sun than Earth, I know it has to be answer choice F. All right, congrats, you did it. And I hope to see you again.